Okay, good morning everybody, or good afternoon, or whatever it may be, but this is the lesson for 912, and it is lesson 2-1, module 1, lesson 2-1. So here's what we did yesterday. We first looked at designs and how to come up with the formulas, okay? So if we look at this patio, what I notice is that this one first starting stone has 2 added to it. This second patio stone has the 2 added to it, but then again 2 more added to it. This patio stone has 3 stones and then 2 added to it. If n is really going to be 1, 2, 3, ... then this patio would be just an n plus 2, because n is 1, plus 2, and then you have to add in these 2 stones, always plus 2. Now, as this pattern continues, then you add another layer. So if it's design 2, you've got 2 layers. Design 3, you've got 3 layers. So we would have for area, we know area of a rectangle is length times width. So to get the design 4, we'd have a n, which is 1, 2, 3, and then 4, times the n plus 2, because you're adding 2 onto each of these, and then plus the 2, plus the 2 to add on that one and that one. That is going to be an area formula for this patio. Now, continuing with that, okay, if we look at this pattern and we want to continue to add to the outside, if design 3 is, we can see there's 3, 3, 3, 3. So if n is 3, we've got 1, 2, 3, 4 of those. So if we want to add the next one, we're going to add on another layer. And then if we continue this pattern to the 4th one, we would add then again, this would be this many 4, 4, 4, 4. And then what we're doing is we're adding our n. In this case, design 4 would be 4 of these, 4 of these, 4 of these, or 4 n's. But then you've got to add in one of these, one of these, one of these tiles, and one of these tiles. So design 4 would be 4n plus 4. Okay. So that's probably the simplest way to create the next term. So if I need to know how many stones are in the 4th design, I would just use this formula. Okay, so the 4th design would be 4 times 4 plus 4, which would be 20 tiles. We have 4, 4, 4, 4. There's going to be 16, 17, 18, 19, 20 for the 4th design. And this formula is going to work for the 5th design, 6th design. Now, Reese did point out that it doesn't work for design 2 or design 1 unless you let n equal -1, 0. Then design 3 would be 1, 2, which is a little bit different than what I told you, okay? But this formula will work for creating the next design, okay? Now, it goes in to talk about how Ramon thinks you're just always going up by 8, okay? And so thumbs down for Ramon, because actually he's wrong. If you do the whole thing, Ramon would go 0, 8, 16, 24, but that's not right. 32, that's not right, because we know that the 4th design actually had 20. So Ramon's design does not work at all, okay? Miriam's design might work because she's got the 4 times her formula, which is going to be 4 plus 4, which is not going to be 24 or 28, but it's going to actually end up being correct. So now Wilma comes up with this design. Okay, Wilma says, okay, again, here's my 3. She's just looking at the 3rd tile, so there's 3, 3, 3, 3, 1, 2, 3, 4 of those, 4 3s, plus 1, 2, 3, 4. So again, her expression would be a 4n plus 4. N in this case is the 3 tiles, because you're on the 3rd level, the 3rd design, okay? Now, continuing with this, Howard says, I got another way to do it. He goes, I'm going to say that I've got this and this, okay? That's going to be my, now remember, we're on the 3rd tile. 3rd tile, so n has to equal 3. So he's got 3 plus 2 more. 3 plus 2 more. So he's got an n plus 2, and then he's going to put in these 3, this 3, so he's got another n. So Howard says, okay, it's 2 of the n plus 2's plus 2 of the n's, okay? Now, Tyler says, wait a minute, the way I would do it is, okay, now if, again, we're on the third tile, here's an n, there's 3, 3, 3. I got 4 of those. I got 1, 2, 3, 4 of these. So he said, okay, if n is 3, remember n is 3 because we're on the third tile, so you can go n, or the 3 plus 3 plus 3 plus 3 plus the 1, 2, 3, 4 in the ends. Okay, all right, so that's his form. Okay, Tamara says, wait a minute. The way I'm going to do it is I'm going to take the big outside square and then subtract the inside square. And what I'd have left is the border. So she says, okay, well, the outside square would have the 3. Here's my 3 plus 2. So n plus 2. Same thing, I'd have an n plus 2. And to do area, n plus 2 times n plus 2. Area of a square minus the inside, which is, well, n is 3 in this case. Again, n is 3 because we're on the third tile. I'd have n times n. So, or n plus 2 squared minus n squared. Now, the big thing is they're all the same formula. They really are, okay? I like Wilma's better because Wilma's is easier. So if I turn the page to page 18, I like Wilma's. 4n plus 4 is simpler than all the others. So if we take a look at, here's Wilma's, 4n plus 4. Howard's is 2 times n plus 2 plus 2. And they all simplify to be the same. And Tyler's expression and then Tamara's expression, they're all the same expression. And if I want 135 tiles, okay, to create the next design, I say, okay, how many? Okay, so what we're doing is this. If the whole thing is 135, 135, 135, 135. So if this is 135, how many total tiles we need? We just plug it into our formula. We get 544. Plug it into Howard's formula, 544. Plug it into Tyler's expression, we get 544. And we put it into Tamara's expression, 544. So the difficult part about this lesson is coming up with the formulas, okay? So then they're all the same. So you just have to use the one you like, okay? And again, we can prove that they're the same. Even Tamara's, I did all of the math here. Here's Wilma's. Howard's, I simplified Howard's, I multiplied through, distributed. Got the same answer as Wilma. I took Tyler's, and I know that n plus n plus n plus n is 4n. Same as Tamara's, or Wilma's. And then Tamara's, if I FOILed this out, the n squareds cancel. So they're all the same. Which one do you like better? I like that one better. Okay, so that's the lesson. Homework was a worksheet. It was this lesson. We did skills practice, page 7 and page 8. And I actually gave the formulas because they're very difficult. I just needed you to evaluate. Here's the expression. These are easy. I gave you the expression. You just had to evaluate, okay? All right, that's what I have for today, which was actually yesterday.